I'm Anil Kumar, sharing with you how to factor difference or sum of cubes. Now, treat it as a supporting document for all the students who are taking calculus now, as I realize that some students take after a break and they have really forgotten some of the formulas. This is a very useful formula which you'll always need to factor, right? So let's begin with a cube minus b cube. How to factor this? Formula is written there. A cube minus b cube will be a minus b times a square plus ab plus b square. If you have a cube plus b cube, then here we'll have a positive sign and negative at that place, correct? Now let us say we have a function f of x which is a cube minus b cube, and we have to factor this function a cube minus b cube. In that case, we'll look for values of a which can make it 0. So here you can see b equals to a, or a equals to b, I should say. I should write or a equals to b will make it 0, right? So if I write what is f of b is, so I am substituting a equals to b, correct? So f of b will be b cube minus b cube, correct? Which is clearly 0. That really means that we have a factor here, and the factor is a minus b, right? Since b makes it 0, a minus b is a factor of a cube minus b cube, right? I hope you got this concept. Now, what is the other factor? How do we find that? We could do it by long division or synthetic division. So I'll follow long division, as some of you might have forgotten even synthetic division. So I'm trying to be, using simple techniques to help you out remember what you learned long time back. So we'll now multiply by a minus b, a cube minus b cube. So we have a cube minus b cube. If you remember, in between we have to fill in those terms which are missing with a powers of 2, 1, right? This is 0. So I could write this as plus 0 times a square plus 0 times a. We have minus b cube, right? Now, this is a to the power of 0, which is 1. So that will make it easier for us to divide. Dividing by a binomial will take two terms. So we have to multiply by a square. That gives us a cube minus a square b. And when you take away that, you get, this becomes positive. You get a square b here, that is 0. Bring down the next term, which is 0 times a. Now, we need to multiply by a, b, right? So that goes in the quotient. When you multiply by ab, we get a square b minus a. We are left with ab here, that is 0. And then we'll bring the mistake here. When I multiplied by ab times minus b, I should have got ab square, right? ab times minus b. So I have ab square here. I'll bring down b cube. Now once I bring down b cube, I have to divide ab square minus b cube by a minus b. Now I should multiply by b square, right? Now I should do it by b square, so let's do b square. When you multiply, you get ab square minus b cube, and that gives you 0. So indeed a minus b is a factor. And what is the other factor? Well, we can now write this as a cube minus b cube as equal to product of a minus b times the quotient, which is a square plus ab plus b square. You get it, right? So that is how you can see how this formula comes into existence, right? Now, you could practice doing with the other form, that is to say, now we can factor what is a cube plus b cube is, correct? Now here, if I substitute a equals to minus b, then minus b cube plus b cube becomes 0. That means that a plus b is factor of a cube plus b cube. right? Same steps. Now let us do this division and then figure out factoring of a cube plus b cube. You can actually pause the video, do it yourself, and check with my solution. That could be a good practice question for you, right? Now as we did here, we'll write a cube plus b cube with filled in for zeros, right? 0, a, and then we have plus b cube. Perfect. Now first two terms, if you take, you have to multiply by a square, since we need to make it a cube, right? So we have a square b, and when you divide this, we have minus a square b plus 0a. So now you need to multiply by minus ab, correct? That gives you minus a square b minus ab square. And when you take that away, you get ab square plus b cube. And now we should multiply by b square. And that gives you ab square plus b cube, which is indeed 0. And therefore, you could also write that a cube plus b cube is equals to a plus b times a square minus ab plus b square, right? So I hope the proof is very clear and straightforward. It also helps you to recall how to perform synthetic division or long division. Well, this is long division, and we are going to use this formula extensively in calculus. So now let's take up related questions on calculus where this formula can be used. Thanks for watching and all the best for calculus advanced level.